Hello everyone. On behalf of all the co-authors, I am going to present our paper titled Complex Daily Activities, Country-Level Diversity, and Smartphone Sensing. This is a large-scale study done with over 600 college students in Denmark, Italy, Mongolia, Paraguay, and the UK in the context of Project WeNet. The field of activity recognition has gained substantial attention in recent years due to its usefulness in various domains, including healthcare, sports, transportation, and context awareness. For instance, fitness tracking mobile health applications enable users to access activity-specific metrics. Similarly, smart home systems can make changes to the environment such as lighting and temperature based on the information gathered about people's activities. Further, the context awareness, a key aspect of mobile phone user experience, is enabled with the integration of activity recognition. In this context, the traditional approach to sensor-based activity recognition is limited by cost and maintenance, while commercial wearables are often seen as niche and are abandoned after a few months of use. However, smartphones have great potential due to the widespread ownership and unobtrusive nature. Furthermore, country differences can significantly impact smartphone usage, including social norms around phone use. Because of this, passive behavioral data collected from phones also differ across countries. However, there is limited understanding of how country diversity affects the smartphone sensing pipeline, including the impact on model generalization across countries. This is mainly due to logistical difficulties in conducting studies with the same protocol across diverse countries. Now let's focus on the activity types that can be considered in activity recognition problem. In literature, multiple types of activities have been considered, each at different granularity levels. Coarse-grained or simple activities like walking, sitting, or cycling are repeated unitary actions directly measurable from a proxy, like the inertial censored unit. Fine-grained or complex activities, or activities of daily living, are built on top of simple activities but convey more specific contextual information. For example, eating, studying, working, and movie watching entail participants sitting. Such activities cannot be measured by inertial censored units alone and need a more holistic multimodal sensing approach that captures a wide range of contexts and behaviors that build on top of simple activities. So, detecting complex daily activities that can better inform about people's daily lives is crucial in the post-pandemic world where remote study and work settings are common. In summary, the current state of research and how we approach the problem is shown here. Prior studies in activity recognition focused on using inertial sensors to detect simple activities and were mostly conducted within a single country. So, the understanding of how multimodal smartphone sensors could be used to detect complex daily activities that can better inform about people's daily lives and how such models generalize to unseen countries is limited. That is where our study comes in. So, we asked 3 research questions. First, how are complex daily activities expressed in different countries, and what mobile phone sensor features are most useful in discriminating different activities? Second, can we use a generic one-size-fits-all model for complex daily activity recognition across all countries? Or is using country-specific models better than the generic model? Finally, the third research question, do models trained in one country generalize well to other countries? To answer these research questions, we did a large data collection campaign. So, data were collected from over 600 college students in the 5 countries, namely Denmark, Italy, Mongolia, Paraguay, and the UK. All the participants installed a mobile application on their phones, and this application collected sensor data from 10 modalities passively in the background. In the meantime, participants reported what they were doing hourly throughout the day. These reported activities are the ground truth in our study. The study was done for 4 weeks, and the whole study was GDPR compliant across all countries. Further, all data processed for this study were anonymized data. Then, using all the self-reported activities, we came up with 12 common activities that were present across all countries. They include attending classes, working, studying, resting, and eating. As you can understand, these are not low-level simple activities, such as walking, running, sitting, and climbing stairs, that are considered in typical human activity recognition problems. In this context, using all sensor data and a 10-minute time window, we trained models to infer complex daily activities in 3 different approaches. First, country-specific approach, where training and testing data come from the same country. Second, the country-agnostic approach, where the testing country is unseen during training. This approach allows us to examine model generalization performance. Finally, we have a multi-country model that have data from all countries. Now let's take a look at each research question separately. Regarding the first research question, on the one hand, we found that similar features are most informative for all countries for specific activities. On the other hand, for some other activities, the most informative features vary across countries. Interestingly, however, they remain approximately similar across geographically closer countries. For example, the sport activity has the use of health and fitness apps as a top feature across European countries. However, the feature was not prominent in Mongolia and Paraguay, where such physical activity-related app usage is lower. This divide is also visible in the watching something activity, which is influenced by the use of entertainment apps in European countries and not in the other 2 countries. Next, we have the second research question. To answer this, we defined and evaluated a 12-class complex daily activity inference task with country-specific, country-agnostic, and multi-country approaches. We also used population level, that is not personalized, and hybrid, that is partially personalized models, to evaluate how model personalization affects performance within and across countries. We showed that the generic multi-country approach, which directly pulls data from all countries, achieved an AUC of 0.70 with hybrid models. In a way, this is a typical approach used in many studies, when multi-country data are present. Then, we found that country-specific models perform the best, with AUC scores in the range of 0.79 to 0.89 across the 5 countries. These results suggest that even though multi-country models are trained with more data, models could not encapsulate all the information towards better performance, possibly due to the averaging effect of diverse behaviors across countries. Hence, the country-specific approach consistently worked better. In answering the third research question, with the country-agnostic approach, we found that models do not generalize well to other countries. We got AUC scores below 0.7 in the population level setting. With hybrid models, personalization increased the generalization of models, reaching AUC scores above 0.79, but not up to the same level as country-specific hybrid models. Moreover, even after partial personalization, we observed that models trained in European countries performed better when deployed in other European countries than in Mongolia or Paraguay. This shows that in addition to country diversity, behavior and technology usage habits could be what mediates the performance of models in different countries. In light of these findings, we believe that human-computer interaction and ubiquitous computing researchers should be aware of machine learning models' geographic sensitivities when training, testing, and deploying systems to understand real-life human behavior and complex daily activities. We also highlight the need for more work to address the domain shift challenge in multimodal mobile sensing datasets across countries to train models that generalize better. For more information and detailed results, please read our paper. Thank you.